The solar car is a all-encompassing, all-consuming pursuit. Everything else goes out the window. Girlfriend, parents, friends.
1, 2, 3.
Eating, sleeping, certainly.
It was worth it because it changed my life completely. When you make something and you can see it working, it's just amazing. Actually being out there and driving a car that you built yourself is just incredible.
Most of the students on our team find it really easy to find really great jobs when they graduate from Stanford. So we have folks that go into companies like Boeing or SpaceX, Tesla.
The solar car experience was the most important thing I did at Stanford. There will be classes that you took that you don't remember at all. But going to Australia and driving your car across a continent under the power of the sun and only under the power of the sun together with your friends is a defining experience that you will remember until the day you die.
So I'm really excited to be here today. We're here to celebrate our 25-year history at the Stanford Solar Car Project. The Stanford Solar Car Project was founded in 1989 here at Stanford by some really driven engineering students. It's an entirely student-run group. What we do is we design, build, test, and then finally race solar-powered vehicles. So we compete every 2 years in something known as the World Solar Challenge. It's a really large event held in Australia. We are required to drive 2,000 miles across the entire Australian outback, just using solar power alone. It's a really competitive event. It's really difficult. This past race was one of the most exciting in our recent history. Our latest car, Luminos, which raced in the 2013 World Solar Challenge, this very grueling race, it did very well.
Hands on the car, hands on the car.
We're here at the start of the 2013 World Solar Challenge. Over the next couple of days, our team will be driving around 2,000 miles across the Australian outback. We think we have a very robust vehicle that's also efficient. So we're looking for a top 5 finish hopefully in this year's race.
The race itself has teams from about over 20 other countries. It allows you to see that there are like really good engineers and meet really good engineers from every country and every continent in the world.
Hi, that was good, totally.
And I really think that's a really cool part of the experience.
This year we had 15 or 16 team members from Stanford. They're participating in the race.
I do love World Solar Challenge. It's so pure as a race. Just point A to point B, first one there wins. Point A to point B happen to be 2,000 miles apart across the most inhospitable land on the planet. I love that.
I found that I really like collaborative engineering. I have a lot of fun because I get to work with a lot of really smart people at Stanford.
I'm a rising sophomore at Stanford. I'm majoring in mechanical engineering.
Try going a few degrees more vertical. Okay, stop.
I've actually taken 3 quarters off for solar car. I will finish in 5 years, which will be 12 quarters of school. And my major is computer science.
I'll be a 5th-year senior when I get back from this race in computer science.
So I'm an economics major at Stanford, and I've been spending the last 2 years working on this vehicle, Luminos, and I also raced with the team in 2011.
There are 3 classes that compete in the World Solar Challenge. The class that we competed in is the Challenger class, and that is straightforward racing. You have one person in the car, you're trying to go as fast as you can.
All the teams begin in Darwin, which is on the northern coast of Australia. And from there on, the teams are racing head-to-head to Adelaide, which is the finish line of the race. Darwin, Australia is a very special place in the minds of a lot of people on our team. It's in the subtropics, so it's hot, it's humid, there's a lot of mosquitoes and other bugs. And then on top of that, there's crocodiles, plenty of dangerous, poisonous things. We usually set up ourselves in a hostel. The majority of our time in Darwin is spent at a racetrack called Hidden Valley, focused on doing last-minute preparations for the race itself.
I'm Max Praslin from the Stanford Solar Car Project. I'm an electrical engineer on the project, and I've been working with the team for about 2.5 years.
I joined actually about exactly a year ago, and just the fact that I'm here in Australia now is pretty crazy.
In the World Solar Challenge, the teams that place in the top 3 will actually receive recognition in a big medal. So basically, the gold, silver, and bronze teams are kind of the top teams the next 2 years throughout the globe. For the last 6 or so races, there's been 2 teams that have traded back and forth winning the World Solar Challenge. The Dutch team, Nuon, and also the Japanese team, Tokai. And then the University of Michigan is also another top team. They've consistently been in the top 3.
There's always naturally a little bit of a competition between Michigan and Stanford. We were focused on them. We wanted to beat them. They wanted to beat us. That's a good rivalry. Michigan is a fantastic team, and Michigan provided all the incentive we needed to sort of pull those extra late nights.
We were kind of in the dark with respect to Twente. We had gotten to know these guys, and they're really funny people.
Yeah, definitely one of the fastest teams in the whole race. Very good team, master students in the Netherlands. They take a year and a half off to do it. They build a beautiful car, races very fast.
One of the cool things about our team is that we're completely student-run, and our university involvement is really there to support us, not to direct us. A lot of these other teams are run by professors. They're either completely or mostly grad student composed, and it was really cool for us to see how these other teams are run that were really a lot older than us, a lot more experienced.
Right now we're at Darwin Showgrounds, where they're staging the event Scrutineering, where all the teams that are competing in the race this year go through about 4 hours of regulation checks with the officials for the race.
Not related to famous Henry Ford by any chance?
Not that I know of.
I mean, it's worth having a look.
One of the first stations that our team goes through is a battery check station. At high noon, when the sun is high above the sky, our team will use a solar array to charge those batteries so that at the end of the day and in the early morning when the sun is low in the sky, we can still cruise at the same speed using the extra energy stored in our battery pack.
I'm curious to see what other teams have for their battery packs. Most teams keep them pretty under wraps. This was just a station to go through and you put orange string across the pack so that if we were to tamper with any cells, it would be obvious that something had happened. It's just sort of a safety check that they have, that teams are following the rules. Hopefully in the course of the race, we'll never open the battery pack again, and we'll open it in Adelaide, and the string will still be on, no problems.
Thank you very much.
Thank you.
Lovely looking.
Thank you.
Delighted to see it, so good luck in the event.
Great, thanks.
I'm expecting big things of you.
We'll see, we've been practicing. One of my main projects was building the battery pack mechanically. Max Praglin did the electronics and Rachel Fenichel did the code.
Merry Christmas, have a battery pack.
Oh yeah. Okay, got it.
You start the race with a full pack. You're fully charged in Darwin, and you end the race with an empty pack. So some days later. So you don't discharge to 0 every day, and you don't recharge to full every day.
My other role on the team as of recently has been working on our race strategy, and part of that is having good models of the car. So I've worked very carefully to identify how the car performs in different conditions, and then use that information to decide how fast we drive the car.
If you go faster, you're actually burning quite a bit more. Sometimes it'll be better to go faster by 1 kilometer an hour over a long period of time, rather than faster by 5 or 10 over a short period. It depends on what your strategy guys are saying you should do. It depends on what you think the weather will be ahead and whether you have to outrun clouds, stuff like that.
3, 2, 1, go.
One of the more fun parts of scrutineering is the driver egress test, whereupon the driver must be seated inside the car with their seatbelt on and get out of the car, and I believe it's 12 seconds.
So out of the car.
But the way it works is you get locked in the car and you have your harness on and your helmet on and the radio, and they give you a countdown.
3, 2, 1, go.
And then timer starts and you have to get out all by yourself. A lot of things could go wrong that would require a driver to get out of the car immediately. Most obvious being some sort of a fire in either electronics or the battery systems, which do happen. With Luminos, it was pretty easy to get in and out of.
Some folks actually have to transform from designers to race car drivers, like Anna Olsen. One of the roles that you played in Australia was that of driver. And can you explain for everybody, what is the experience like of driving Luminos?
One of the most challenging parts about driving the solar car is that it's extremely boring. Your only job is to sit there and keep the car between 2 straight lines on the road. There's basically no air movement inside the car. You're basically sitting in a little black carbon fiber box. It's definitely unpleasant, objectively speaking, but at the same time, you're driving a solar car across Australia. That part never gets old for me.
Our organization has kind of a dual purpose between providing educational experience for the students on the project and making a really high performance vehicle. should I redesign this? Should I do something new? It would be a little more educational for my members. So really navigating the trade-off between good race performance and doing things that are new is probably the toughest challenge.
My name is Alex Tilson. I'm a 1992 graduate of Stanford. So I was at the very first meeting that the Stanford Solar Car Project has ever had. It was freshman year, 1989. No one had built a solar car before.
It's the first drive we're doing in Australia.
I was the first to take the car to Australia and the World Solar Challenge in November of '93, where we were 13th, I believe, out of 40 that started roughly. And that remained the Stanford speed record across Australia for 20 years, much to our surprise. The teams that went subsequently didn't finish. I know at our company, our entrepreneurial success, I partially relate back to the solar car experiences. It taught me a lot as a leader, taught me a lot as a manager, taught me a lot as an entrepreneur, taught me a lot as an engineer.
The solar car team and technologies are usually ahead of their time in terms of looking at the next best generation of batteries, the best solar panels, best motors and efficient converters, things like that. Most of my involvement with the solar car team was toward the end of when I was at Stanford. I had many friends that were part of that team throughout my time there, and I recruited most of the people from the team when we started Tesla, and was a key thing in the beginning of Tesla. I think it matters more than most classes you can take. I mean, it's one of the things that even today at Tesla we look at on resumes and place it higher than perhaps GPA, or even perhaps higher than what classes they've decided here and there.
So the process of getting our solar car from basically a blank sheet of paper with no ideas yet to having a vehicle that can be ready to race across the Australian outback takes our team about 18 months. It's a very quick cycle. We'll spend about 3 months doing preliminary design work. Once we get to the mid-fall, we'll start doing some of the manufacturing work. The vast majority of the components of the vehicle we actually manufacture here on the Stanford campus. For example, the carbon fiber composites, we ramp that up in the late fall going into the winter. Basically the entire vehicle's composite monocoque chassis and exterior shell is made out of carbon fiber. We have a lot of titanium components on the vehicle. We have very high efficiency solar cells on the top of our vehicle and the solar array. And our team usually spends about 2 or 3 months doing testing here in California for the most part. For example, we'll spend a lot of time in the Central Valley where there's a lot of open farmland where our team can do testing that's a lot more similar to the Australian outback. We've also done some wind tunnel testing in the past, even out in North Carolina.
Key word for that cycle is testing, testing, testing. We actually put the full length of the race on the car in test miles in the United States, which is a challenge most teams haven't been able to accomplish.
This year our team was very fortunate in that we had a couple hundred great sponsors that supported our team. Altogether, the program this cycle had about $1.6 million worth of parts and cash that were donated to our program. Of that, maybe $400,000 was cash, and the rest were parts that were donated to our team. For example, Panasonic was one of our big sponsors this year that provided battery cells for our vehicle.
So the Stanford team assembled hundreds of our cells into various blocks. Those blocks were assembled into a battery pack, and they did all of the integration themselves, complete with a battery management system. And this is an amazing effort considering these are young adults, many of them not even officially graduated yet, and being able to pull this off was really, I think, quite magical.
Another one of our big sponsors was ST Microelectronics that provided a lot of the integrated circuits for our vehicle this cycle.
These microprocessors are kind of the center of what our software team works on. And this is a little integrated circuit that we use on pretty much every circuit board on the car. The invisible software that just makes everything on the car work and have all the different elements on the car talk to each other.
We've been sponsoring it for, I believe, 6 years now, okay, and we'll continue to support it because now we're very involved, right? And it actually goes quite fast. I accelerated. I thought I'd scare the crowd by driving at them, and they got the message, get out of the way. This way. It was great. No, it was good fun, good experience. What I was fascinated by was how they do everything on this car from scratch. It's an amazing achievement for undergraduates. They have to still study and get their homework in, as we all know, okay, on time, and get their projects done. At the end of the day, it's also a lot of fun. And I think that's what comes across. They really enjoy it and are very enthusiastic. And that's it. And like all semiconductor companies, there's a method in our madness. We're a European company. We're in the middle of California. What better place to become famous is with the next generation of engineers, right? Catch them early, as they say. So it's a fantastic project to be involved in. It really is. It's better than even I expected. I mean, people have been telling me about it for years, but now I've been up close and personal, if you like. It's impressive, really impressive.
For the summer, our big deadline in the sand was to get the car in a boat 7 weeks before we needed it in Australia. Usually our team will ocean ship our car because that's the most cost-effective way. This last year I tried to make a big effort to try to find a corporate sponsor that could support our team with air shipping, but I had very little success for months on end until I got some inroads with Virgin Australia and Virgin Atlantic.
Air shipping is something we always talked about doing, but it's hard. And Wesley manages all in the background to get this sponsorship. It reinforces the opinion that he's magical.
Wesley was amazing at logistics.
So solar car, turn left here. Okay, solar car, clear to proceed. Beautiful.
Greg was great for technical advice, knowledge, and they were just both fun people to be around.
Coffee. Greg. Coffee.
They did a fantastic job.
So with our team, we definitely have a lot of very passionate, strong personalities.
Because the thing is, every time water drips out, we're wasting water.
But fortunately, this year we had a very strongly knit group of students that were out in Australia. By the time we got to the race, we were really functioning as a well-oiled machine.
The car is still on?
Fortunately for us, Stanford University provides cash support, but we still operate on a pretty tight budget when we're in Australia.
We weren't dining out every night, but no, we're not starving. And also, this is partly because the team tries to put most of our money into racing. You can live on PB&J for a while.
The one large expense that our team members have to personally cover is the flight ticket to Australia. And for many members of the team, that's a barrier that prevents folks from being able to go to Australia to experience racing in the outback. In addition to the solar car itself, our team has a convoy of vehicles that we use to support the race car. So this year Volkswagen provided us with 4 vehicles to use, and our team picked up those vehicles in Melbourne, Australia. The first vehicle that we have in our convoy we call the Scout car. For one, the Scout vehicle is responsible for collecting live weather data just ahead of our team and reporting that back to the rest of the convoy. They'll also report if there's any kind of new road hazards we wouldn't expect.
Australia does have a lot of kangaroos, and they're actually primarily nocturnal creatures, so they'll kind of get attracted to this road surface at night when the road is warm and the weather's cooled down a bit. And the problem with this is that there's road trains, these 3 or 4 trailer long semi-truck configurations. What they have adopted is, they'll call them roo guards, where it's just a steel grate in front of the truck. They won't stop because they can't stop, and they'll just run these kangaroos down. And it happens, there's roadkill on the road, and we have to navigate that the next day.
The next vehicle in the convoy is called the lead vehicle, and this vehicle will run maybe 500 yards in front of the solar car itself. And then just behind the solar car is the chase vehicle. And the chase vehicle is usually kind of the headquarters of our race convoy. And then the final vehicle that we have in our convoy is our trailer vehicle, which we use to carry all of our tents, all of our camping gear, and also some of our race equipment as well. All the teams today got a chance to race their cars around the Hidden Valley racetrack, and the team's racing time on the racetrack is what the officials use to determine the grid order for this year's race.
Well, it's a little bit nerve-wracking to be the one doing the hot lap, just because the whole team's kind of counting on you. Everyone's worked really hard to get us here.
The Stanford team did very well. We came in with a 2-minute, 7-second race time. That was the 3rd fastest in the challenge class. So that means that we'll be placed 3rd car at the start of the grid for this upcoming race.
So the day before the race, I felt ready, and I know a number of other people on the team have also felt ready.
I've been doing solar car for 4 years, and this is probably my last shot at it.
So today is race day. It's a little surreal to be here.
We're all obviously very pumped up, a lot of adrenaline flowing. None of us have slept all night, waking every hour in anticipation of the day. We're just really excited. It's going to be a great race and a wonderful way to see Australia.
We hope to win.
I'm excited, our team's excited.
Feeling good, got a good night of sleep, and we're ready for a long race.
You kind of start to reflect a little bit on 18 months of everything. I mean, the sleepless nights, the joy of something working, the bickering about what is the best design, what's not the best design, just the agony and the ecstasy of it all. So my parents have decided to come to be the, as they call it, drive the chuck wagon for the team.
Like my wife says, we're chief cooks and bottle washers. We're making sure that the team stays full.
We're the cookies.
They'll be making our food and just handling the food logistics for the whole trip. The nice thing about that is it means the team doesn't have to worry about food. They can take a big chunk of work off of the team and leave us to sleep and make sure the car goes really fast.
Really excited. It's been a long process, and here we are. The door was, at Thanksgiving 2 years ago, was a piece of cardboard, and he was, designing it. So it's just fun to see it go from the idea to this.
The other guy that came was named David Olson. He was a fantastic asset to have because he knew outback weather really well.
I believe that at the present time we're looking at some bad weather towards the last day, what we hope to be the last day of the race. If we can get there and fast enough, we should be able to avoid the worst of it.
And then if we don't go fast enough, we could run into some bad weather near Adelaide. With a solar panel, you can see your power drop to near zero with a cloud in front of the sun. And we think that if there's enough sun, that we should be able to have enough energy in our batteries to make it down to Adelaide. But it's really kind of a scary game to play when you don't know if you're going to make it to the very end.
I'll be driving the first shift, which is exciting, but it's probably one of the more complicated shifts just because you're in real city traffic. The nice thing is I've got, the convoy knows what to do, we're rehearsed at this, we've done this, we're ready to go racing.
On the first day of the race, the teams are released off the starting line every 30 seconds or every minute or so.
Getting out of Darwin was quite an adventure, and there were a lot of teams. It was just very dense traffic, a lot of passing, very chaotic.
Over the course of the race, there's 9 or 10 control points that teams hit in the biggest cities on the Stuart Highway every few hundred miles. The biggest cities might be a city with a population of 30. As the teams come in, their racing clock will stop for a period of 30 minutes, so teams can buy food and water for the next day of racing, refuel their escort vehicles. So at this control point, we'll do a little bit of work on the car that's a little bit superficial, so things like checking for bugs on the array, making sure the tire pressure is okay.
Basically, the thing is that you want to evaporatively cool the array, and as they heat up, then we start spraying them. We use deionized water or demineralized water because it means that we're not leaving residue on the array.
Yeah, getting a little more power than expected.
Nuon, which is a team from the Netherlands, their car Nuna 7 has concentrators in it. So these are magnifying devices, and that gets them a lot of extra power. It's legal. You do get a lot more sunlight onto every cell.
Nuna and Twente are in front of us. We passed Michigan a short while ago.
Michigan.
Yeah,
Michigan's way back. They just pulled in. Yeah.
So we have pretty good sun coverage right now. There's a bit of clouds, but based on our weather data, the clouds should clear up pretty soon, and hopefully we'll have clear blue skies between here and the next control point. As the teams continue for the rest of the day of racing, before they get to the end of the race day at 5 p.m. each day, they'll have to try to scout out a place to spend the night. So what the team will do is quickly pull their vehicle to the side of the road, and then oftentimes what they'll do is they'll take their array of the car, the solar panels, and try to prop them up so they can point the solar panels directly at the sun for the last final hours of the day.
Finally being in the race was definitely exciting, although that sort of wore off after the first hour, and then it was just a struggle to keep wiping the sweat off your face, and but it was a good time.
3, 2, 1, up.
We're fourth now currently, and ahead of Michigan. I got to pass Michigan and looked over and grinned at their car while we were driving by.
And as long as we stay in front of Michigan, we'll be happy for now.
ミシガンの前でさ、ビクトリーから走りたいから、その後。
今僕らミシガン。
Well, is Michigan back behind? Is that it?
Yes, Michigan is just down the road a little ways behind us.
Oh, we didn't see them. We missed them.
Oh no.
Good to know.
We set up the array stand, picking a position where we're going to get the most sun that we can.
We need to rotate the back of the car closer to me.
What they can say is, okay, I think that you should go up by this amount, and that's kind of eyeballing it based on angles that we can see.
All right, that's pretty good.
But then after they say, I think we should do this, they can actually check. We have a telemetry system, and so we're getting data from the car directly to a laptop.
I can see the numbers.
They can say, okay, we're getting 5 more watts than we had last time, so this is a good angle.
Ready for food. And then looking forward to the stars out in the outback. That's one of the coolest parts about camping out here.
We wake up before the sunrise, we get the array stand out, we push it upright and we point directly at the sun. And then what people do is we adjust the angle of it back as the sun goes up, still keeping it pointed directly at the sun.
It was nice to camp in front of Michigan for the night. We'll see how long that trend can hold. But overall things went really well yesterday, despite it being a very stressful and hot day. We were happy with how things turned out. The car's doing really well so far.
Are we good in the rear fairings, guys?
Fairings are the way we make the car aerodynamic around the wheels. So the fairings come down off of sort of the main body of the car and shroud the suspension, the brakes, and the wheel and the motor. And so the fairings are something you need to be able to get on and off to change tires. We took the fairings on and off a lot of times.
Razor. Cut it? This is not on very well.
No, you need to redo it.
No, it's flush in the front.
Okay, cut it.
Cut it. Toby, hurry!
Our team makes a large investment in ensuring that the people that go to Australia understand their roles and have a good sense of unity with their team members. There's definitely other teams that may have a lot more drama, so as much as we can, we try to avoid any kind of conflicts we would have at the last minute when it comes down to actually racing across the outback. It wasn't really until all the cars were out in the race course we really knew how our team was going to stack up against Michigan and the Dutch teams and the Japanese teams that had often beaten us in years past. This year, the Stanford team had a couple of alumni from our project that were tagging along with our team, most of which were from Google actually. They were rooting our team along. They were also doing some recruiting at the same time.
What SolarCar does do that's really good is it's just the absolute best training ground for new engineers to really get some experience under their belts before going off into the world.
The last few people who have joined the Google X, self-driving team mostly, have been from like the Michigan SolarCar team, the Minnesota SolarCar team, and the Stanford SolarCar team. I guess I should say that SolarCar is about like 95% of the reason why I got my job.
It's pretty hot. The car's feeling pretty good though. It's pretty stable. It feels good.
About how long were you driving and about how many kilometers?
About 5 hours.
We're pretty happy with where we are right now. If you'd said 2 years ago that we'd be here, we probably would not have believed you.
Yeah, we're excited to be top 5 so far. Really happy with how the car's doing. No major problems, no. Not yet. You never know.
Today I'll be the driver in the afternoon, going from Tennant Creek, where we currently are, down to just a little shy of Tea Tree, it looks like. I haven't seen the latest models, but last I'd heard we'd be pretty close to there tonight. We're in the outback now, and you can kind of tell. So it's a little more sane driving. You can run your own race now as opposed to having to jockey with other teams a whole bunch. So it's a little more relaxed in that sense.
Jamie, do you have a hammer?
Yep. So we're camping up for the night and getting ready to eat some steak.
How's this? That's half a beef.
Michigan's still an undetermined but few kilometers behind us. So that's kind of fun to still be this close at that point. And Twente, we think, is about 20 to 25 minutes ahead of us. It's nice to be within 30 minutes of a podium at the moment.
Good morning, Sword. We're gonna have to have a lot of people though to make sure it doesn't. It's gonna want to tilt like this and hit the tail.
Famous Outback recipe. Ready for flipping? Yeah.
It's containing kangaroo.
Yeah,
these
I
pancakes.
got the baby wallaby batch.
Baby wallaby batch.
Yes,
okay. Yeah.
They're good.
Dude, they're mad tasty.
The food has been very good. I definitely can't say I was expecting to eat this well in the middle of nowhere. On this laptop, I have a set of graphs and numbers that are reading live data off the car.
Say solar car passing on the right.
And the idea is that by looking at the live data off of the car, I can match that up to our predictions that we've made. So within a few minutes of noticing that we have more power in our battery than we had originally planned, I can look at our numbers, see what speed we should go to kind of match our predictions.
The biggest city that our team hits over the course of the race is Alice Springs, which is right in the center of Australia. The Stanford team is well over halfway through the race now. We've been cruising anywhere between 85, just over 85 kilometers an hour on a daily basis right now, which is fast for our car, fast for a lot of teams.
All right, brakes.
My name's Peter Collins. My duties as an observer is to observe the activities of the team and record anything that might be a little bit out of the abnormal and pass it on to the officials. So since leaving Darwin, I've been with 3 different teams. It's good fun, and of course coming home with all the teams is a wonderful experience because you do meet some young people who are our future, and I think it's rather exciting to see them at work.
Oh, you found some wood. Got the Barbie going. So yeah, if they're little, you don't. If they're, we're just trying to get them more like half size.
9, 10, perfect.
I cut the carrots, and I got somebody to cut the broccoli. We're having curry tonight. I'm done.
On the fire and see what happens.
Our team is aware of some teams that have probably dropped out at this point in the race. There's 2 Dutch teams, then 1 Japanese team that are still ahead of our vehicle. But in terms of the competition behind us, we're pretty far ahead.
This one's got a few cuts, but nothing troubling.
Anna, check.
Yeah.
You check.
Everything has been going very well so far. The car has not broken down. We've been sticking within a few kph of our projected speed from the first day. We have plenty of battery pack. There's a lot of good sun right now. It looks like we're going to keep up a tailwind until we get towards the coast. And from there, it's kind of questionable what will happen. We're looking at a storm system kind of rolling in from the ocean when we arrive in Adelaide. So looking forward to another day of driving really fast.
We had really strong tailwinds going into Cooper Pedy, so not all cars are built to handle these kind of winds. Unfortunately, one of the cars, University of Michigan, crashed today going into a control stop. Unfortunately, they're okay, but it's unclear what their status is in terms of racing. But that'd be a pretty big upset for them. They've been the fastest American team for about 2 decades. We started the day 45 minutes behind Twente and are now 5 or 6 minutes behind them. It's cool to be right up there, you know, neck and neck with another team. It's pretty weird after, you know, 2,600 kilometers to be right on someone's tail.
I think everyone is starting to get a bit tired of camping in the outback. I haven't taken a shower since the morning of the race, which would be 4 mornings ago. And we're soon coming up on some very fly-heavy areas. I'm not a fan of the flies.
Tomorrow's going to hopefully be our last day of racing.
The next day we knew it was going to be cloudy, but it was a question of how much cloudy we would have to deal with and when and where the rain might hit us. This was a photo of us huddled around our laptops trying to decide what we were going to do on the last day of the race. So our decision that night was that if we got any bit of sun in the morning, we would try to catch Twente. And that meant that we were going to throw all of our best practices for race strategy out the window. And this was kind of a calculated gamble. We knew that if we caught them, it would be worth it. And if we didn't catch them and ran out of energy, we might be stuck on the side of the road.
Good gamble, makes it fun, makes it exciting, makes it really, really freaking stressful on the last day.
So that last day, waking up 6 minutes behind Twente was definitely exhilarating. We figured they probably had more on the battery pack than we did, but we wanted to keep pressure on them, hoping they would make a mistake. We know they were worried about us. It was really fun to be in an active race that late in the game against a team that we all respect so much.
We had a short drive from the place that we had camped the night before to Port Augusta.
We're at the last control stop right now. The Solar Team Twente is in 3rd place, and we're about 10 to 15 minutes behind them. So right now we just kind of have to brave this terrible weather.
But our team was trying to get the last potential wattage out of our solar array, so we had our team propping our vehicle up to get a bit more sunlight to improve the power output of the solar panels.
Hey Wesley, what time do we leave again, just so we know?
It's really going to be a race to Adelaide. Don't know if we have enough sun to get there. Don't know if they do. If we got 0 sun, we surely won't make it to Adelaide. It's about 200, 300 kilometers from here. It's just a question of how fast do we go to try to save some energy. It's a high stress time right now.
And after the 30 minutes were up, we had to jump in our convoy vehicles and try to chase down the Dutch team that was just ahead of us.
So the rules of the race dictate that we must always be traveling at least about 35 miles an hour when we're on the road. And for the last day, we went about 35 the entire way.
The most stressful point in that drive from Port Augusta to Adelaide was when the motor had started to cut out already, meaning that it was very low in battery pack. And we're coming up to the largest grade on that section of the track or the race course, and we were at the bottom of it. And it was raining very hard. My vision was highly obscured by fog, so I couldn't see very well. About halfway up, I realized, uh-oh, we're not really gonna make it. Luckily, there was a little rest stop and a pull-out at the top of the hill. I personally needed to use the facilities as well as wipe out the condensation inside the cockpit, but once we got to the top, it was literally downhill from there.
Fortunately, we only had to stop twice briefly. Unfortunately, the Dutch team Twente ahead of us had a bit more energy, and they were able to pull away from us on the final day of racing.
I feel really great. We just finished with the car. We became 3rd. We were pretty close at Stanford, and they were constantly like 15 minutes behind us. It was such a pleasure to race with them.
So I was really happy that we got a little bit of sun in those last 30 minutes or so that were able to drive us through the finish line. So my first error was stopping apparently about 6 inches short of the line. It was a really nice culminating experience, getting 4th place. Last drive I'll ever have in a solar car.
To America's #1 solar car team!
Made it! Yeah! 3,000 kilometers! Yeah.
Got a little shaky at the end, but trucked on through.
Awesome. Like, we're the first team to finish for Stanford in forever, and we did it properly. We didn't break down.
I'm going to take a nice long shower and get rid of this red Outback dust all on me. And then I'm going to take a long nap.
Yeah! I'm so excited. So happy. I was so nervous. Nail biter. It was a nail biter.
Feeling relieved. Fourth place, best finish ever, I think, for Stanford, so couldn't be much happier.
Great. We're at the finish line, end of timing, and we're very happy.
More flies!
The next car we expect to have here on the finish line will be the Stanford Solar Car project from the United States.
So what happens here is the chief energy scientist checks all the battery seals.
Thank you very much. I like this pack, it's nice. Not a speck of dust or anything on it. Congratulations, it's a very nice pack.
Thank you.
Yeah, it's really good.
The team this year did very well. We're very happy with our results and having the best finish in Stanford's history.
It was fabulous what they did. The team had been in a 20-year Australia rut, and we're thrilled that the team went and obliterated the '93 Stanford performance and beat Michigan. Really was the top all-student team in the world. Hats off to Wesley for heading it up and for everyone else for being a pivotal part of it as well.
There's also usually an award that goes to teams that are recognized for their, spirit in the event itself.
The 2013 Bridgestone World Solar Challenge, the David Fuchak Spirit of the Event Award, is presented to Stanford.
And that's just an effort to recognize teams that are doing something special to make the World Solar Challenge really an exciting and fun event for everyone involved.
And this award is yours just as much as it is ours. Thank you, everyone.
I would easily rank the Stanford Solar Car experience as my top experience I've had here at Stanford, but there's still some lingering stress, I can say, from the last year and a half, and I'm sure I've taken months, if not years, off my lifetime by the amount of stress that I've gone through.
One of the reasons that you can kind of justify to yourself putting so much time in it is because it's kind of something that society needs a little bit. So beyond just the educational thing, there's also a cool kind of showing society what's possible, you know?
Maybe this much in energy to get from Darwin to Adelaide to start out.
Almost 2,000 miles
yeah,
on a few bucks of energy if you were charging it off the grid. So
it's not a bad deal.
Yeah, it's not a bad deal.
After I got back from being in Australia, I began my job search to find a full-time career, and I just recently joined Google working on their self-driving car project.
What do you need?
Right.
So I'm graduating in June, going up to Yosemite for a week to relax, vacation, and go hiking. And then I'm going to start working at Google X, writing code as a full-time job.
This just isn't flat. Yeah, I was working at Tesla the spring and summer leading up to the race. So now I'm full-time at Tesla in the Battery Design Engineering Group. There's no question that I would not have gotten my very first internship at Tesla without what I learned at Solar Car.
I certainly hope that the university continues to, put resources behind this and also stay out of the way enough to provide a place that students can really have that freedom so they can, push the boundaries, fail occasionally, learn from the failures, make mistakes. That was one of the, I think, instrumental parts of Solar Cars. There was never a safety net to prevent you from making really bad mistakes. And you learn amazingly quickly in an environment like that.
It's a little bittersweet to see it finally end, but I'm glad I got to go out on a very high note like this, and I have so much confidence in the people that are coming up. We just had such a great group of young people join this year. The team's in great hands. Can't wait to see what comes next.
That's what's really incredible about this experience to me, is that you join as a wide-eyed undergrad with no concept of anything that you think would be useful to the car at all, and then eventually you realize that at some point between Australia and where we are now, the wand has been passed down, and it's our turn to build a solar car.
Thank you.